Okay, so this is an assignment that I have given in the past. You may be asked to do it again, but this is where we are going to create a layout, and I want to go through all of the steps from beginning to end here, with a couple exceptions here. Um, we are not going to create our own footprints or pad stacks. We are actually going to use some of the default ones that are built into the Cadence system. Now, typically that is not done, but to simplify the process for us, we are going to skip the pad stack and footprint creation for this particular one. So this really is focusing on coming up with the circuit schematic and then also um, taking that schematic and getting the footprints in, and then net listing, importing, and doing the layout. So the first thing we need to do is take this circuit and draw it up in Cadence here. So I'll do a new project. Where am I even saving this here? Save this in ECE 1000. I'll just create a directory. I'll call this assignment 10 because that's what it said on the top there. And I'll just even call this one assignment 10. We'll talk about what the circuit does a little bit later on here. But I'm going to create a blank project and then bring it up here. Now, the next thing I want to do here, I'm going to kind of play with my screens just the tiniest bit here. Oh, I did not want it to go back to full size. That's good. I'll just leave it for here for now. So I can basically, here, let me widen it so you don't have to see my background of running water. Okay. Now, in this document, I did this so that we can actually see the assignment and my drawing at the same time. It tells me the libraries that I need here. So let me open my place parts and see if I have all these libraries. So I need the analog library. Okay, got that. I need the bipolar library. I don't have that, so let me add bipolar. I need the diode. I don't have that one either, so I'm going to add the diode. And then I need the connector. Okay, got the connector. Capsim. Okay, got that one. And then I need the breakout. Okay. And it said be using footprints, so I don't need that yet. I need the schematic here. Now, let's go ahead and first try and place this 555. Actually, they forgot to put one library here that we needed, and I've already got mine added in. You need the ANL underscore MISC. That stands for analog miscellaneous. So that's very important here. You need that one as well. Or if you're following along in the video, you won't be able to do what I'm doing here. So we need the ANL underscore MISC, analog miscellaneous. So you might say, okay, well, I don't know where this 555 alt part is. Well, one thing you can do here, and we haven't really talked about, is I can select all of those libraries just by holding my left mouse down and just dragging it, and then I can just go ahead and start typing 555, and oh, look, 555 alt. There's also a B and a C here. We're going to use the alt, but then it also has the part. So I could just double click on it right now, which is what I'm going to do. But then it also tells you what library it's stored in. It's in the analog miscellaneous library. So I'm going to go ahead and put it in here. Now, let's go ahead and notice a couple things first. First off, this one looks bigger than this one as far as the box. The name's in a different location. The pins are even in a different layout. And the reason for that is I actually went in and changed that. And the reason I did that is that when I looked at the data sheet and I saw how all of the pins were connected, because I was basically here, let me even show you what I did here. If I just go 555 timer data sheet, because that's what this is. I don't want to go that way. That's an ad. Just pull it directly up from TI's website. Um, I'm just quickly scrolling down, but you can see, look, there's different layouts, like as far as how to connect things up here, and there's also different circuits as far as how to lay them out. And so that's kind of why I did this, is because when I was designing the circuit, I'm like, so I don't have to have wires crossing all over each other. I said, okay, well let's move these pins around. So let's go ahead and do that. Let's go ahead and edit the part. And this is one thing, as I said right now, on a single click, but I can make this, I can make it as big as I want. So I'll just go a little bit exaggerating, making it much bigger. I'm going to go ahead and put the name here in the middle. Okay, so then if I look here, the output's still there, but where did the trigger go to? The trigger went, and I'm just going to select the pin, then I'm going to left click and hold onto it. Whoops, I went down too far. And I have a cat now that's walking over my keyboard. That's helpful. Okay, so let me do that again here. Oops, that's the name. So you select the pin and you can kind of move it around where you want it to be. So trigger was here, and then the reset was over here. VCC was kind of right here. Discharge was at the top. Then I had threshold here, and then the ground pin I had moved over here, and the control pin was moved over here as well. And then I'll just go ahead and hit close, and it will say, what do you want to do? Update all, hit yes. And so now my part in my circuit diagram, now it's even bigger than the one here, but I can see how the pins are in the same orientation here. And I have a cat walking across my keyboard yet again. Go away. You're not helping. All right, so then let's go ahead and play some of the other components down here. Well, again, I have all of the libraries selected, and there's this R1 that's 10K here. This is a potentiometer, which the short for potentiometer is pot. And so it's in the breakout library. So I'll double click on that, and that's only because it was called R1. Do the R for rotation, just place it there. Place my other resistors. Let me make sure there's no other resistors. Nope. Place some capacitors. Okay, so we have a couple other parts here. We have this QN2222, which is a transistor. It's in the bipolar one, but again, if you didn't know where it was, just select all of them and do Q2N2, whoops, not B, 2N2222. And you can see, yeah, it's in the bipolar one. And so I'm going to place it here. And then what else do we have here? Okay, we have these two things. These are called diodes. So you can probably guess they're in the diode menu. But I'm just going to go ahead and have all the libraries selected and do D1N 41, and then, hey, 4148. So I'll just hit enter. Now notice that they're kind of in two different directions. One is facing to the right, and then I'll rotate, and the other one is facing to the left. And then finally, there are some connectors here, which are just headers. And so if I just do header 2, I'll put one down there and then one over here. And then we do have these VCC bars. And so, but those aren't parts. So I'll turn the part menu off just for now, or I thought it would. I put down an extra component here by accident. So let me X out of that. So now what I'll do is I will do those VCC bars. So I'm going to do this VCC bar. And notice I didn't even change the name of the VCC bar, and that's because there's only one power supply. So I just left it to be just the same VCC bar. I really should have maybe identified what the actual power supply is for this. As a side note, it's a 12-volt power supply. And the reason it's 12 volt, a lot of DC motors are 12 volts. There's also 5-volt DC motors. But then LEDs, a lot of LEDs are driven, if you're talking about those strips, like those strands of LEDs, those are driven with 12 volts. And so that's something we also are going to use here. And then I have grounds that I need to place. So let me do the G, and then I've got a bunch of grounds that I need to put down just to kind of get a rough copy of what this is. Okay, now this set of 0.8 is actually kind of irrelevant. That has nothing to do with the layout, but if you want to change it, you can. That has to do with where you've set the potentiometer, because the potentiometer is a variable resistor. It's like a little knob that you can turn left and right, or actually it could be a slide as well. All right, so then I'm going to go ahead and change these values to what they are. This is set at 10K. This is 100. This is 100. And then this resistor was 4.7K. And then let's go ahead and start wiring everything up. And connecting all these wires up. Whoops, I made a mistake there. See how there's that line that's straight through the diode? I accidentally made a connection that went all the way through the diode. So I definitely don't want to do that. Actually, in the picture, the ground was in a slightly different location, but that's okay. Now, if I look at where these are connected, this is actually I don't have mine spaced exactly the way that it was in my diagram in the original one, but I'm kind of still drawing them that way so that we don't have things interjecting all over each other. I mean, I could have moved some parts if I wanted to make it exactly like the one I had pictured. All right, so now I've wired it all up, and I have my diagram now. So the next step will be to assign the footprints to it. So we'll do that in the next video, is assign the footprints to this circuit diagram and go from there. To wrap up though here, maybe um, to tell you what this is, this circuit, it's called a PWM, which is pulse width modulation. And the way this works is this transistor kind of acts as a switch, turning on and off. Um, but then this pulse width modulation is at a high enough frequency that this transistor is turning on and off so fast that really what's happening is it's like there's only a certain level of voltage getting to, or a certain amount of current getting through. And so if these pulses are very wide, so that's why it's called pulse width modulation, if the pulses are wide, um, then the LED or motor, well, the LED would be brighter or the motor would spin faster. If the pulse widths, the widths of the pulses are very narrow, the motor would be spinning slowly or might not be spinning at all, and the LED would be very dim. And so that's how you can use it to kind of control the brightness of things, the speed of motors. There's lots of other things you can control with PWM signals as well. But you'll learn more about those particular types of signals in future classes.